All right, hopefully you got some good time to work on the Pythagorean theorem worksheet. Now we're going to move to 9.6, the distance formula. And the distance formula really is just the Pythagorean theorem, and we're going to talk about that in a minute. But when we're given any 2 points on the coordinate plane, we can find the distance between those 2 points. And if you just think about it in your mind real quick, if I have 2 points, no matter where they're at on the coordinate plane, I can draw a horizontal distance and a vertical distance, and then I have a right triangle. So the distance formula really is just the Pythagorean theorem. So let's move on. Distance formula. Used to find let me show you this. Used to find the distance between 2 points on a coordinate plane. So if I label my first point x1 comma y1 and my second point x2 comma y2, then here's how it really is the distance formula. This horizontal distance right here, right there, that distance can be found by taking one of the x values minus the other x value. So that's like my A. And my B is the vertical distance, which is just the difference in the y values. And that should give me c squared, but here we're going to call it distance. Or, sorry, if I take a squared plus b squared, that would be c squared. So think about what that would be. If I take a squared plus b squared equals c squared, which is just a right triangle, I would replace those with x2 minus x1, because that's the length, squared, plus y2 minus y1, the length, squared, is equal to, and we're going to not call it c anymore, we're going to call it the distance between 2 points, so it would equal d squared. But instead of calling it d squared, I just want to solve for d, so I'm going to take the square root of both sides, and d equals the distance formula. So it says here, memorize this formula. You actually don't need to memorize it. Just write it down, you can use it. So there you go. 2.5 minutes, and we've just talked about the formula. Let's talk about how to use it. So let's graph each pair of points, then find the distance. And let's go ahead and use the distance formula. So let's graph these first. So the first one's at 2, 3. It's going to be right there. The other one is at -4, 6. So -4, 6 should be right there. Okay, we want to find the distance between these 2 points. Okay, yes, I could just use the Pythagorean theorem and solve this. Go ahead and do that on the assignment if you want to. But I'm not going to do that. I'm going to use the distance formula because that's what this lesson is. So let's go ahead and use the distance formula. Let's write it one more time. Distance equals the square root of quantity, meaning in parentheses, x1 minus, or x2 minus x1 squared. Now think about it. When I take a difference, the difference could be negative, but when I square it, it has to be positive. So we're never going to be taking the square root of a negative number. Because when I square these, y2 minus y1, even if that value is negative, I'm going to square it, it's going to be positive. So I'll always get 2 non-negative numbers added together and then take the square root. So let's plug in what we know. You might want to label first, just like we did when we found slope, x1, y1, x2, y2. Let's plug these in. Distance equals the square root of x2, which is -4, minus x1. Here we go, we're going to be given a negative, -2, squared, plus y2, 6, minus y1, 3. That one's not negative, but you'll see that when we square it, it becomes positive. So let's use a different color. The distance equals, hopefully you can see that, distance equals, when I take -4 minus 2, that's -6, so -6 squared plus, and 6 minus 3 is 3, so 3 squared. And last time I checked, -6 times -6 is 36, positive 36, and 3 times 3, or 3 squared, is 9. So really I'm taking the square root of 45. Yeah, that's the distance. Could I leave it like that? Yeah, but the honors classes know how to simplify this. But let's go ahead and, since it's not being specific, it's not telling us that to leave it in radical form, let's go ahead and find the decimal value of this. So push square root of 45 in your calculator, and you get, sorry about that, you get 6.71 units. We're not talking about inches here. We just are units on a coordinate plane. Okay. If you are one of my honor students, you do know how to simplify square root of 45. Square root of 45 can be written as the square root of 5 times the square root of 9, and you do know the square root of 9 is 3, so this is just 3 root 5. Just saying, we talked about that first quarter. You may not remember. Okay, let's try this next one. We graph the 2 points, and I'm going to show you that you could just use the Pythagorean theorem here. So the vertical distance of this right triangle is 12, the horizontal is 5. You could use the distance formula here, but we're going to do the Pythagorean theorem. 12 squared is 144, 5 squared is 25, so you get the distance squared equals 169. Take the square root of both sides and you get exactly 13, so the distance between these 2 points is 13. Okay, so this next example, it's asking us to use the distance formula, so we're going to go ahead and show that. And let's start by labeling our points, x1, y1, x2, y2. And then remember the distance formula is the square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. Plug in your values. So the distance is the square root of negative 2 minus 8 squared plus 3 minus negative 20. But remember, minus negative is really plus. So we get negative 10 squared plus 23 squared. And we get 100 plus 529. Take the square root of that, that's 629, and we get, rounded to the nearest hundred, 25.08 units. Okay, the next example is, let's try this. Same type of thing. So I'm going to let you go ahead and, if you want to try that, you can, but we've shown the distance formula twice now. So I'll show you this real quick. So we want to start with labeling our points. It's going to kind of go fast. So label them x1, y1, x2, y2. Plug it into the distance formula. And then you get the distance is 8 squared, or square root of 8 squared plus 15 squared. That's 64 plus 225. So you get the square root of 289, which is 17 units. And there you go. Let's try the next one. This is the last example. And we want to determine the mileage between cities for their frequent flyer programs. So the airlines superimpose a coordinate grid over the United States. Even though some things are taken out of the equation, the Pythagorean theorem is going to work. So the units of this grid are approximately equal to 0.316 miles. A distance of 3 units on the grid would be 3 times that amount then. Suppose the locations of 2 airports are as given. 132, 428. There's the coordinates of one airport, and the coordinates of another is 254, 105. Now, do you see where the distance formula would come in handy here? Yeah, you could still draw a triangle for this. You just have to do the subtraction, and the distance formula takes care of that for you. So let's show this real quick, and then we'll be done. Okay, so for this last example, we're going to use the distance formula. We set it up. This is going to kind of go fast. We take the difference in the x's, square it, difference in the y's, square it. When you square those, you get 14,884 and 104,329. Add those together. Take the square root now. I'm going to pause this a little bit, and we get 345.27 units. That's not miles.
Jimmy Barton, please come to the office. Jimmy Barton.
Sorry about that. So we need to multiply this by 0.316 miles. So when I multiply this by the amount of miles that each unit is, I get 109.11 miles. So there you go. Just be careful on these assignments. Make sure you read the directions carefully on problems such as this, and you guys should be good.